Hello everyone and welcome back to your YouTube channel. As you must be aware, we are creating this series of videos to discuss about functionality, property, and how to use the time domain simulations inside DIgSILENT Power Factory. And today I have this amazing video for you. Okay, this is a beautiful video talking about balanced RMS simulation. Okay. In the previous videos, I was discussing about time domain simulation, different type of dynamic simulation approaches, and so on. We discuss the use of the classical RMS simulation, AMT simulation, using three-phase representation or using positive sequence representation. That was an amazing discussion. But this video today that I am presenting to you, it will be based only for balanced RMS simulation, okay? What I'm trying to say is that the discussion from here for until the following videos, it will be based in one very specific type of time domain simulations. And the specific type of time domain simulations that I will be working, it's called the balanced RMS simulation. That is what we will be doing here, okay? And let's start the explanation here. The balanced RMS simulation is basically dedicated for the main topics that we are covering in the class master level of power systems, okay? Power system analysis, power system dynamic, also advanced power system, okay? And these balanced RMS simulations, they can be used for interest on several aspects, okay? The first thing that you need to know is these balanced RMS simulations, they are very good for including the phenomenon related to the electromechanical processes, I mean the behavior of the synchronous machine, but also another kind of controllers and thermal devices. What I'm telling you is that this balanced RMS simulation can be used to include the behavior, for instance, of the governors, the AVR, and some other devices that they are relevant for this time step, okay, for this time scale, sorry. And it's very interesting because when we are working just with the balance simulation, that means that the network representation is very simple. Because for balanced power system, we are working with three-phase power system. For balanced three-phase systems, of course, the representation is extremely simple because you just need the positive sequence, okay? Because the transmission network is basically a passive network. I mean, they are only resistors and reactance, capacitive reactance, and inductive reactance, okay? It's a very passive electrical network that can be represented using a linear model. It can be admittance or it can be impedance, okay? And another thing that is extremely important here is that this kind of simulation, it's only considering fundamental components. That means that we assume that during the transient, the only frequency that is produced is 50 or 60 hertz, the fundamental frequency, okay? That means that voltages and currents, for instance, they can be represented by phasors because phasors assume constant frequency, okay? Then this simulation type, the balanced RMS simulation, can be used for several kinds of studies. For example, we can study startup or loss of generators or loss of motors, for instance, sudden increase or decrease of load. Also, if we are assessing some sort of protection, for instance, emergency protection, emergency controllers like protections, we can use this kind of simulation for assessing under frequency load shedding, for instance. Or we can use this kind of simulation to replicate the behavior of losing a transmission line or a transformer or any kind of symmetrical short circuit like three-phase short circuit, okay? This is a very powerful tool for simulation. That is the reason that I am explaining this today, because also you can study many other things like changing the reference of one controller. For instance, what's happened if we have a problem with the AVR, automatic voltage regulator, and one of the reference voltage change. What will be the effect? Or for instance, what's happening if we change one electrical parameter inside the network? What will be the change in the performance? And that is the kind of things that we can do. Okay, what you need to remember is every electrical variable will be represented by RMS, and what you need to understand is that the network that we are considering is symmetrical balance, and as a consequence we are using only positive sequence. Okay. Power Factory have the possibility of including many studies. Okay, Power Factory has the possibility to be used for transient stability, for midterm stability, for oscillatory stability, for motor startup, many things. If you go to my video about overview of DIgSILENT Power Factory, you will see many other features. Okay, Power Factory is well equipped in terms of calculation functions. Okay, but what is important that you understand is that Power Factory is so flexible that allows you to move between different kind of studies, and everything will depend of couple things, but the most important thing is the events. Okay, you will be able to define your own events. I mean, Power Factory have the possibility that you can the user define the events. Okay, of course, in this case, because we are working with balanced RMS simulations, the only events that we need to care of is symmetrical faults only. Okay, that means three-phase short circuit. If you are thinking about a single line to ground or one line open, etc., that is unsymmetrical. That is not here. Okay. Well, but I have explained so much theory about the DIgSILENT Power Factory modeling, and now it's time to explain how to do that inside Power Factory. Okay, in this video we are talking about just in theoretical aspect. Okay, I mean I will be talking about DIgSILENT Power Factory, but I will not open at the moment DIgSILENT Power Factory. I will explain how to do things at this moment using this presentation, using several videos, and then we will go for a live session and we will run these simulations in real time. Okay, and let's discuss what is the process of a transient simulation. Okay, a transient simulation is a very interesting process. There are several ways to do it, to be honest, but there is a general rule. Okay, if you go to the user manual inside Power Factory, you will find these 6 steps that you can see here. Okay, on the left-hand side, you can see that there are 6 steps. First step, calculation of initial condition. That is fine. Second step, definition of result variables. Third step, definition of simulation events. Fourth step, simulation, execution of the simulation. To be honest, that is the moment that you are running the simulation. That is the only moment that you are running the real simulation. Then you have a step number 5, or the 5th step, creation of simulation plots. And finally, exporting result. Okay, that is the typical approach. Again, if you have the opportunity to read the user manual of Power Factory, you will find the 6th step that I put over there. To be honest, identical. You will find that in the user manual. On the right hand side, I put here a process. Okay, because this process is more generic. Okay. I call the first steps the setup, because the first step will be, again, calculation initial condition, definition of events, definition of result variables, and definition of output graph. Okay, and then we run the simulation. That is the moment that we press the button, and finally we run the simulation. And after that, if you need to create additional result graph, you can do it. And also, there is a possibility that you want to do a sensitivity analysis, you redo the simulation, changing some parameters, and that is a iterative calculation method, okay? And finally, you can print up or export the results, okay? If you use the approach that is presented here on the left-hand side, that is the approach presented in Power Factory. On the right-hand side, that is another approach. To be honest, you can use the left hand or the right hand, but at the end it will be the same output. Okay, it's just the way that people think, is the way that people do the job. Okay, I will tell you something. Here I use the icons. Okay, you can see 4 important icons that they are located inside Power Factory. The 4 important icons. One important icon that is initial condition, and that is the command initial condition. Then we have a command that can be defining the events, defining the results, and then you will run the simulation. To be honest, those four icons, they are the most important icons that you must be familiar if you are interested in running dynamic simulations. Those four icons, they are essential, and you will be pressing them for long and many times. Okay, I highly suggest that you be familiar. Again, there are 4 icons over there: initial condition, defining events, adding result variables, and finally running the simulation. That is all. Okay, that is all. You can see here on the top, they are the icons for the new version, and below you can see the version, the old version. Okay, both of them, they work. All of them, it's possible to use. Okay, but now let's start to explain those steps one by one. Okay. Okay, the first step of this dynamic simulation inside DIgSILENT Power Factory time domain simulation is calculating the initial conditions. Okay, as I say before, initial conditions, they are different. They are not the same as load flow. Okay, load flow is basically a calculation where you obtain the steady state. You consider the steady state of the power system, and for instance, you obtain the state variables, in this case, voltages, powers, and so on. Okay, load flow is just basically solving the network in a steady state. Is basically obtaining the load flow. Okay, that is the load flow calculation, obtaining voltages at load buses, obtaining reactive power in PV generation units, and so on. However, when we are talking about initial condition, that is another history. First is a different icon inside Power Factory. It's a different icon. Okay, the 3 arrows, the famous 3 arrows, they have changed in color, but the shape is the same. Okay, the 3 arrows representing active, reactive, and an apparent power, they stay over there. That is the symbol for the icon of load flow, and load flow is calculating the steady state condition of the power system, but is not related with differential equations at all. Okay, when we calculate the initial condition, that is another history. Okay, the first thing that we need to do is select the RMS simulation method. We need to define that we are using the balance condition, and we can go deep and define many other things. Okay, but I need that you understand, as I did in the practical example, that load flow is one calculation and the initial calculation is more than a load flow. To be honest, the calculation command initial condition is doing more. Okay, because when we use the calculation command for initial conditions, to be honest, inside Power Factory is calculating a load flow, And then after that load flow, all the internal variables, all the internal operating status of controllers, synchronous machine, and any other dynamic components, they are calculated. What I'm telling you is that the command, the calculation command, initial condition, take into account the differential algebraic equations. But the thing is that they simplify the differential equation assuming a steady state. What I'm telling you is, okay, when you press the command, the calculation command, initial condition, Power Factory obtain the load flow calculation. And that load flow calculation, for instance, is the terminal voltage or the terminal angle, okay? And then Power Factory do the following. They take, Power Factory internally take the differential equations, make equal to 0 the differential equations, and if we make 0 here, we obtain a set of equations equal to 0, but this set of equations has inside the state variable and the uncontrollable variables, okay? That means that from here we can extract the value, the numerical value of the state variable. And that is what is doing the command initial condition. The command initial condition may equal 0 the differential equation, extract the state variable, calculate the state variable in terms of a number, and then you can obtain all the initial states, okay? Initial states depend of the model that we are talking about, but for instance, if we are talking about the classical model of the synchronous machine, we can say that it's calculating the load angles or the rotor angle, it's calculating the excitation voltage, it's calculating the steady state speed, it's calculating the mechanical power, okay? That is what is happening, okay? What is happening is basically Power Factory is calculating all the initial states, okay? Because the initial state is the starting point for the dynamic simulation, okay? Then we have step number 2. Step number 2 in the simulation, there are people that they use another step before this. I will use here step number 2 as the definition of events, okay? Remember, events is any change that we introduce inside the power system in order to excite the dynamic processes, okay? It's similar to the events or disturbance when we were talking about power system. In power system, when we have a disturbance, it's because there is a change inside the power system. This is an event here inside Power Factory. The event is basically the definition of changes inside the network. Those changes can be in many ways, okay? For instance, one very basic example that everyone understands. We have the network working in a steady state. Then we have a short circuit. And that short circuit is during a TF time, okay? And that is the fault time. Yes, we have here the fault. Suddenly the fault is clear and we have some time. And probably we can have a reclose event, okay? That means it's trying to close again the circuit breaker and try to see if the fault was successfully removed. To be honest, these kind of events can be simulated inside Power Factory in many ways, okay? There are different type of events that you can use inside Power Factory, but also you can combine several events as well. That means that you can include an event that is called short circuit, then we have one that is clear, the short circuit, then we can reclose the circuit breaker, and so on. Power Factory allows to do this. You can include as many events as you want. Basically, Power Factory has already, I believe, 16 or 17 different events that you can define. And they are extremely configurable, okay? You can change the configuration. You can change the configuration of every single of those events, okay? Here there is a list. I don't remember if this is 2000. This is coming from Power Factory 2020 or 2019, but here there is a list. 17 events. Okay, they are dispatch events. They are external measurement events. They are, for instance, load events. They are outage events. They are short circuit events. They are, I mean, here Power Factory has done a very good job providing to you several kind of objects. Each of those objects represented a very specific event. Okay, what you need to do is you can go to the user manual, and over there you will find more description. Okay, you can define more description. Just for general information, every single of those events every single of those objects defining events, you will find that they will have 3 letters at the very beginning, EVT, that is for representing events. Okay, it's a good idea that you start to understand how Power Factory speak in order that you understand better the things. Okay, and EVT that represent events. Okay, for instance, we have the switching events. Switching events, they are extremely simple because they are affecting a circuit breaker, and the circuit breaker has 2 status, open and close. Okay, and when we are working with switching event, you can see over here at the window, you can see EVT. I say before 3 letters, EVT representing the event, and this is a switching event. Okay, what you need to configure is the time, because we are running time domain simulations. You can define 1 second, for instance, but then you need to define the breaker element that you are working, because that breaker must be located anywhere, for instance, in a generator, a transformer, load, transmission line, whatever. You need to define where this breaker is connected, and then you can define the action. Okay, the action can be close the circuit breaker, or it can be open the circuit breaker. Okay, usually if we need to disconnect a power plant, for instance, we can use this switch event and we can say open the circuit breaker. Okay, however, keep in mind that when you open a circuit breaker, it's like in real life. If you open a circuit breaker of one generator, you can have the problem of this generator speeding up. Okay, you must be careful about. You must understand that Power Factory is a software for real real situations. Okay, and also one more configuration, you can define the circuit breaker as 3-phase or single pole. I mean, you can order to open or close in 3-phase way, in 3-phase fashion. That means that 3 poles open or close at the same time. Or you can use the the most recent approach of opening or closing just a single pole or 2 poles. Okay. There are other events. For instance, there is this event that is called set parameter change. This is the event parameter. I received many email about this because people try to change the inertia or change the resistance of one transmission line, or I want to change the load in one specific load. I want to change the active power, and they email me and say it's not working. Of course not. Of course not. You need to read the user manual. Okay, if you use the event set parameter change, that is only for DSL model. Okay, this event in particular is for use in DSL model. I mean, if you have an AVR, if you have a governor, and you want to make a change inside time constant or something like that, yes, go and use this event. Okay. Another event that is extremely useful, and probably we will be using this for a while, is the short circuit event. Okay, the short circuit event, of course, is to define a short circuit. The short circuit can happen, or you can insert the short circuit, for instance, in a bus bar, or you can select the short circuit to be in a transmission line. If you define the short circuit in the transmission line, what you need to define is basically define the time that is happening, the location that is inside the object transmission line, and then if you want to include some resistance and reactance for this short circuit, okay? That is basically the most used event, the short circuit event, okay? Remember that in this course we are running a balanced RMS simulation. For that reason, the short circuit that you will be using is basically a 3-phase, okay? Because this event can be used for single phase, for 2-phase, and so on, okay? One more event, the inter-circuit event fault, okay? The inter-circuit event fault. The inter-circuit event fault is another kind of short circuit. It's not quite typical. Not much people know about this and use this one, but it's basically similar to the short circuit event. But in this case, we can understand that we can use to represent short circuits in different places at the same time. That is what is happening, okay? An inter-circuit is a classical short circuit that can happen when we have a structure like this transmission tower. We have a circuit 1 here, circuit 2 here, and there is a short circuit in circuit 1, and there is a short circuit line to ground, for instance, and circuit number 2. That can be happening, for instance, because a lightning strike, okay? There is a lightning strike on the tower, there is over voltages, suddenly there is a short circuit between the line B in the circuit 1 to ground to the tower, and the other one in C on the circuit 2, okay? That is something that has happened, and you can apply this kind of inter-circuit fault event in different elements. For instance, bus bar, terminals, overhead transmission lines or cables, etc., okay? Another event, I will be using this one for small signal stability later, and one of these events is basically the synchronous machine, okay? And the event synchronous machine is basically to change the torque, okay? Here in this plot, it must be torque, okay? Because the event synchronous machine, EvtSym, the event synchronous machine is basically changing the torque, okay? You can increase the torque from torque 0 to torque 1, or it decrease also, or define a ramp, okay? It's very important that you understand that this event can be used. For instance, I will be use this one for a small signal stability analysis. Another event that is quite useful, I use this one a lot for frequency stability, is the load event, okay? The load event is an event that allows you to add or to control the active reactive power in a load, okay? You can say, okay, I want to increase an incremental change on the active power or reactive power, or I want to make a ramp increase or decrease for the active or reactive power. This event, the load event, is quite practical, okay? What you need to do is define here if you want the specific time that you want to increase or decrease the load. Then you want to define if you will increase or decrease one or multiple loads, even if you want to use different stages, okay? And then you define the shape. If you want to use a ramp, of course, you need to define the duration, okay, for the increase or decrease. And if you are using a step, what you need to define is just the size of that step. You can use incremental changes in percentages or absolute changes and so on, okay? This is an event that we will be using, especially for frequency stability. We will be running some practical sessions with this event later, okay? Here also there is another event that I use a lot. This is the outage of an element, okay? You can disconnect, but in this case you are switching off the device, okay? The outage element can be used in a steady state, or it can be also used in RMS simulation. And what you are simulating is that the device is taken out of the system, okay? What you need to define is basically define when is happening the situation, and also what element you are taking out, okay? When you finish describing the events or several events that you want to define, the next step is defining the result objects, okay? Let me tell you the following. Power Factory is a very flexible and a very complete software, okay? And as consequence, there are thousands of variables inside Power Factory that you can use for your analysis, okay? You can be surprised about the number of variables that you can access inside the DIgSILENT Power Factory. I have been working with the DIgSILENT Power Factory for years, I will say probably decades. But one of the things that you must understand is that I don't know all the variables, okay? I read a lot of technical documentations, but time to time I am surprised that somebody asks me for one variable. I go to the technical reference and here they are. I mean, it's very important that you be familiar with the technical reference, and you will be surprised about you can get the values of several variables inside, okay? It's very, very important. To do so is extremely simple, okay? There are different ways to define the result objects and the variables, okay? There are different ways to do it. There are different ways to define the result objects and the variables that will be inside. To be honest, the most simple way to define the result objects and the variables is using the classical right button, okay? Power Factory is making easier the life of the rookies users, and also some senior users as well, okay? And a few years ago, they introduced this right button capability, this context menu. And if you are working in the graphic area over your single line diagram, you can stop over one of the power components, for instance, a generator. And if you right click, automatically there is a menu that opens, this one that you see here on the bottom right, okay? And you can select here, define, and then result for simulation, RMS and AMT, okay? What is doing this is basically you can do many things that we used to do manually. Power Factory is creating the result objects and then is defining a set of variable, pre-default set of variable that you can use, okay? That is amazing. That is making your life easy because here you can see that in this case you can see the variables, they are located inside what we call the result objects, okay? We have the result object and inside they are result variables, okay? And the result variables, they can be selected from each component. They are a set of variable, okay? If you have been watching my videos, you will remember, for instance, when I defined the additional test result. And if you watch those videos, you saw how I selected the different variables to show there. And it's the same process, okay? We can use the internal monitoring objects in order to define the variables that you want. What you need to do is select a filter, a variable filter, depending of the representation that you want. Then you can select the variable and then you put here at the variable panel, okay? When you have the variable in the panel, that means it's going into the object, result object, and then you can use for plots, okay? Or you can export the numerical data. What I'm telling you is that this is the simplest way to do it, okay? Many years ago, Power Factory doesn't have this kind of context menu, and it was a bit different, okay? I highly suggest to all my students that they go and read technical documentation, because a classical question is, I need to find that variable. Well, one way to do this is start to look inside those menus and try to find the variable, and the clever way, go to the technical technical reference. Okay, don't be lazy. Go to the technical reference, read over there. You will learn a lot of things, useful things for your career, for your life. Please try to read. Read technical reference is very important. Okay, spend time reading over there. It will be useful for your future career. Okay, try to do so and you will get something useful. Step number 4 is defining the output graph. Okay, Power Factory doesn't have any result variable. We define in step number 3 the variables that we want. But again, Power Factory is so flexible that allow you to create your own output graph. And that is step number 4, okay? Step number 4 is you will create your own output graph. And there are different graphs that you can use for that, okay? There are different ways to plot your results. And Power Factory is very flexible. If you have your variables inside the result variable, it's extremely simple. There is something called virtual instrument, and the virtual instrument, you can imagine the virtual instrument like a white paper where you will create your graphical representation. To be honest, it's extremely simple. If you are using the new version, what you need to do is something similar to Microsoft Excel. Click here and one new virtual instrument or plot page will appear. And inside that white paper, that plot page, you will be able to include any kind of plot that you can imagine. They are lines, they are bar graph, they are gauge, they are vector diagrams, and so on. Okay, what you need to understand is those kind of graph can be selected and be connected with the data result object that you already defined. Okay. Again, when you create a new plot, it's very simple. Just press this positive symbol or positive symbol or plus symbol at the top, and then you will have something like this. Okay. Right now in the old version, you have something like this. We call this virtual instrument, and here we have a new plot page. Okay. In this case, both of them is like a white paper. In that white paper, you will include your graphical results, and that is the next step. The next step is you need to add your plots, and there is a button here in the new version. You can press this button over here, and suddenly Power Factory will ask you, what kind of plot do you want? And there are many different types of plot depending on the study that you are running. If you are running simulations, RMS and AMT, you can select this one, and from there you can select if you want to use, for instance, a subplot XY, or if you want to use any other kind of plot. Okay, you can use any kind of plot inside Power Factory. In fact, Power Factory is so powerful that is also allowing you to do, for instance, frequency process like FFT, fast Fourier transformation, and also if you want to do some other kind of studies. Okay, the most used plot when we are working with time domain simulation is the subplot. Okay, the subplot is the classical representation used for the time domain simulation. It's very simple. We select the subplot, and that is the basic diagram that you can use. And then what you need to do is double click, select the variables, and you will get something like this. Okay, this will happen after the simulation. Okay, if you select the plots and you select the variables, nothing will happen until you run the simulation. And you will run the simulation in step 5. Step 5 is the most exciting moment because you finally, after 4 steps, you will be able to run a simulation. And that is easy. You go here, depending on the version that you are using. There is a toolbar. You must remember this toolbar at the very top of the DIgSILENT environment. You can identify those 2 buttons over here. And the one on the right hand side, this one is the running the RMS simulation. Okay, the old version used to have this this traffic light, this ugly traffic light, and that was the command for running the simulation. Okay, When you press that, you need to configure several things. For instance, the total duration of your simulation or simulation time. And you can define here, for instance, 5 seconds or 10 seconds, and Power Factory will run the simulation over that time, okay? If you are using the old version, this is like the way that the dialog is looking. And if you are using the new version, it's pretty much better. I like this one. And you will be able to execute here. You press the button here at the top right, execute, and you will get the execution done, okay? Perfectly fine, okay? Finally, before we finish this presentation, it's time for a short summary. What you need to do is basically run initial conditions, then define the result variables, define events. You can swap this, okay? You can define the events and then the results is not a problem. The order is not affecting the result here. And the last step and the most exciting, press the button and run your simulation. If everything is fine, you will not get an ugly message. If everything is fine, properly done, you will not receive any bad message on the output window. However, if you make a mistake, probably something will happen over there. You will receive some sound and then some red letters on the output window indicating the error, okay? Well, it's time to say this is the end of this video. This video presents the most important and relevant aspect of the time domain analysis using DIgSILENT Power Factory. As I say in the first video of this series, this is not a training about use DIgSILENT Power Factory for time domain simulation. This is just a basic explanation for basic understanding of my students about that, okay? Now we are running some practical sessions and we will be doing each one of those steps one by one in a practical example, and you will learn how to do it in a practical way, okay? Again, this is just for a general introduction. I highly suggest to my students and everyone watching this video, this YouTube video, please go to the user manual. Please read the user manual. The user manual of DIgSILENT Power Factory is one of the best that I ever seen. It's quite useful. It's quite there are so many information, useful information over there. Please try to read over there. Try to learn from there. Okay. This is the end of this video. I hope you enjoy. I hope you find useful. If yes, please subscribe to my YouTube channel. Stay in touch, okay? And I will see you very soon. Thank you very much for watching, and I will see you next time. Thank you, and bye now.